Good day to you all. You are watching the Algebra 1-2 Chapter 8 video review. All problems are based on that homework number 31. It's a it's a two-page packet. It has front, back on it, so 4 sides. Now, you see the time here. I gotta go quickly, alright? So this isn't gonna be a very slow-moving process. However, some parts I'm going to slow down on. This first page we did before in class, though, so I'll do the best I can to make sure that I review it in kind of a quick way. This here is called the 5-point method in terms of graphing. So let's say you have an equation, and this is all you're given. All right? There's a way to make this graph. Now, this graph has been given for you, but let's say they didn't give you this graph. There's a way to make this graph if you can identify these 5 points here. I'll use that red, these two red-ish ones right there, which will be number 1. This blue one, right, let's see, that's number 4. I think down here is the vertex, is number 2. Okay, this green one, which is number 4, which that can really be accomplished right off the bat, so I think I did that in class as well, so I'm going to find that first. And then number 5 would be this purplish one right here, which is way down there as far as example stuff. And once you find those points, those are enough points that you can create the curve through that. 5 points is definitive. Notice how if these reds were gone, 3 points wouldn't be enough, because couldn't these 3 points also conceivably go this way? The answer is yes, they could. They could have gone like that. They could have also done that as well and curved off that way. 3 isn't enough. You need those last 2 right there to ensure yourself that you have what it is that you're looking for, and that is that specific curve. So I am going to start actually though with number 4 because it's very straightforward. I have this equation right here, and I need to solve for y when x equals 0. This is your y-intercept. And your y-intercept when x equals 0, when it's written in standard form, 0 squared is 0, minus 2 times 0 is 0, minus 3. When x equals 0, y equals negative 3. So that point is 0, negative 3 right there, and then you get to plot the point. Now remember, this is before you have the curve, right? The curve's given for us to help us out, but this is before we had the curve. We have that point there. I'm going to erase these. No, I'll keep them. Okay, then I'll go back to number 1, bouncing back, and the rest are kind of built through getting number 1 and then the rest of them. These are your x-intercepts. We need to find out what these values will be. Obviously, they're supposed to be negative 1, 0, and 3, 0. But the way to do this is you have your equation. You must set y equal to 0 and solve for x. So you substitute 0 for here. I'll go ahead and rewrite this down here. X squared minus 2x minus 3 equals 0. Okay. You do that, now you solve for x. And there are 2 different ways to do that. One way, which we're going to do, is the zero product property. Now this is only possible if this is factorable. And let's check and see if it is. We have x squared, negative 3. Excuse me. We have x squared, negative 3, and 2 numbers that add to negative 2x. So 1 times negative 3 is negative 3. That'll be your product there. These 2 numbers need to multiply to negative 3. They need to add to negative 2. Those 2 numbers are negative 3 and positive 1. So as I fill this out, I get negative 3x and 1x. Either way you need to do it, and then you start working on your factoring. And like I said, I'm not going to spend too much time re-explaining this part, even though this is a part of our chapter. I want you, whoops, I just screwed something up there. I want you to really be able to see what it is we're doing here. When we work from the outside in, these 2 numbers multiply to this number. These 2 numbers multiply to negative 3x. Negative 3 times 1 multiplies to negative 3. And 1 times x multiplies to x. So you have to find those numbers that work, and it starts by working from the x's out here. And I hope we have a lot more problems like that to work through in this hour. Alright, so our factors are x plus 1 times x minus 3. And this whole thing, keep in mind, this is our original equation. What I did was I factored this side, and now that factored side is turned into this. Now the thing that this helps us with is when x plus 1 times x minus 3 is equal to 0, we have this thing called the zero product property. And what that means is if a product of 2 numbers becomes 0, if their result is 0, that means one of these 2 numbers must have been 0. If a times b equals 0, then either a equals 0 or b equals 0. So if I have 2 quantities multiplied together and they equal 0, one of these has to be 0. Otherwise, that's impossible to make happen. So let's go and use that idea. let's say either x plus 1 has to equal 0, or x minus 3 has to equal 0. If x plus 1 equals 0, you subtract 1 from both sides, you'll get x equals negative 1. Or, if x minus 3 equals 0, you add 3 to both sides, you'll get x equals 3. Those are your two solutions. X equals negative 1 or 3. And remember what we really solved for here. We found the x-intercepts. Those are the values of x when y equals 0. So the points negative 1, 0 and 3, 0 should appear on your graph. And that's what those two maroonish points are right there as we plotted them. Negative 1, 0, 3, 0. Okay, moving on. Next part's the vertex. Now, in a parabola, this x squared equation, it's a quadratic equation. You know what? Actually, now that I said the word quadratic, I'm jumping back in my head about what it is that we need to get here. We still need to solve by using quadratic formula, so I'm going to go back to this right now. But I'm just going to say this is a quadratic equation, which also means your graph will be a parabola. By the way, step 3 will be important when it comes to something else, but it's not an actual point. It's just a step. Anyway, so it's a parabola. So I'm going to go back to what parabola means after we do this. So anyway, I want to solve this one by using quadratic formula as well. And I know this page doesn't have very much room. I'll go and do it right down here where I have some room to do this. So in my equation, I have 1x squared minus 2x minus 3. A is 1, B is negative 2, C is negative 3. These letters also have names, or these terms also have names. This is called your quadratic term. This is called your linear term, the one with the x, and the constant, of course, is called the constant term. So my quadratic coefficient, my a value is 1, my linear coefficient is negative 2, and my constant, you can call it constant coefficient, but that's kind of redundant, my constant is negative 3. So we use those things, and when we use quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Just find some way to remember that. There's this inside part here that's called the discriminant. That might be a good starting block for you. Because we don't have much room here. You just want to do as best as you can to make sure that you use this room as best as possible. If I find the discriminant first by using b squared minus 4ac, that number is 4 plus 12, which is 16. Now that's inside the square root, so the square root of 16 is 4. So when we do this plus or minus the square root of b squared minus 4ac, we're going to get 4 as that whole portion right there, including the square root. So as we use quadratic formula, this will be x equals minus b, that's the opposite of negative 2, plus or minus, here is the square root of b squared minus 4ac. All of that is just 4. All divided by 2a. I don't have much room. Let's go. So x equals then, the opposite of negative 2 is 2. It either equals 2 plus 4 over 2, or x equals 2 minus 4 over 2. 2 plus 4 over 2 is 6 over 2, which is 3. 2 minus 4 over 2 is negative 2 over 2. That's negative 1. So once again, we get the answers x equals 3 when y equals 0, or x equals negative 1 when y equals 0. And you only use the quadratic formula in the instance when you're solving for x when y equals 0. So you must have this setup with a, b, and c. On the other side, you must have 0, and you find out what those things are, just as we did down here. Okay, I'm going to move on now. Let's go to step 2, the vertex. I can keep that there. Okay, we have to find the vertex of this guy. Now, I was making a point up here that quadratic equations are parabolas, and parabolas have symmetry. They are symmetrical. And what symmetry means, or what symmetrical means, is that whatever you graph, in fact, I have a shape tool for this for parabola. There we go. Whatever you graph, the left side and the right side will be mirror images of each other. Now, I don't think this will graph perfectly on here. In fact, it won't. But no matter how I shape this thing, notice how it's always symmetrical. Notice how the right and left sides always have the same property reversed of each other. For instance, if I did a parabola right here, let's just do one right there. This one has what's called an axis of symmetry that cuts right in the middle. Boom. That reflects points. Like there are 2 points across here, boom, 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 that are mirror images of one another in parabola. And that's always true. Now that middle part, right there on the bottom, is called the vertex. I don't really know why, but who cares? Whoa! The vertex is the bottom or top point, and that's that blue part right here. So we're going to find out where this vertex lies in the x direction, and then we'll find out what the y point is. I think we can safely assume that the point is going to be 1, -4, but you don't really have this graph yet if you think about it. This is just a toolkit. So how do we find that vertex? Well, there are 2 points right here that we found already, and these are what are called corresponding points. Now, corresponding points are on either side of this axis of symmetry right here, which is what we're going to do next. We can do what's called averaging our x-intercepts, or average any corresponding points, because the vertex will be a point that lies directly in between any 2 corresponding points. Because these are the same height and parabolas are symmetrical. So these are 1, 2, 3, 4 units away, which means the vertex will be halfway in between those 4 units. So if these are 4 units away, vertex will lie in between. So I can go 2 away, 1, 2. The vertex lies at x value of 1. Here is the vertex. You go straight down from there. If you know that the x value is 1, we can find out what the y value is by substituting 1 for x in your original equation. Y equals x squared minus 2x minus 3. So if I do y equals x squared minus 2x minus 3, I'll get y equals 1 minus 2 minus 3, which is -1 minus 3, which is -4. Your y value for your vertex is -4. And there's the point, and that's how we found it without needing to use the graph, or we use these points without needing to use a curve that's already there. Okay. Now the next part, I talked about it a little bit, this line right here. I'll go ahead and draw this line in blue all the way down here. This is called your axis of symmetry. And if you think of axes, here's the y-axis. Here's the x-axis. This is just some other random axis that's going vertically up and down. But this one happens to cut right through. Remember that green line I just drew for that other parabola? This one cuts right through your vertex, which says that I can reflect points on either side of this axis here, and I'm going to land on my parabola somewhere, like there and there. Those are corresponding points. These are corresponding points. Stuff like that. So we can use this axis of symmetry. Now this axis of symmetry has an equation involved in it. This is x equals 1. This is the line, the vertical line, x equals 1. And you want to know what that one is right there. If the axis of symmetry is over here, this would be x equals 5. If we did happen to have a horizontal parabola, which I don't think we're parabola going this way, which we're not looking at all. If you had one going right here, this line would be y equals 4. So you can define the line of the axis of symmetry by going through any of those points there. Okay, so what does that axis of symmetry help you with? Finding a 5th point. So this was step 4, finding the y-intercept here. All right, and I did that first just because it was quick to go through. But this 5th point can be found by knowing that there must be a point that reflects across that's 1 unit away from the axis of symmetry at the same height as the y-axis was, or as the y-intercept was. So the y-intercept's at the point 0, -3. So there must be a point over here called something -3, and we can determine it by saying, well, how far away from the axis of symmetry is it? And you find that out by doing from the y-intercept. So this point is 1 unit away, and this is at x equals 1. If you go 1 unit away again, this would be at x equals 2. So your last point here, this corresponding point, with your y-intercept can be found right there. And that's step 5 way down here. It's the same value as the same y value as the y-intercept, and the x value is different. This is a corresponding point at 2, -3. There we go. And there fills out that page. Now, I said I wouldn't take too long on that, but I did spend 15 minutes on it, so I'm just going to stop right there. Okay. Let's go ahead and graph this thing. And we can use the table. We can also do 5-point method, stuff like that. Check this out. You guys know how to do a table, so I'm going to not do the table. I'm going to do this instead. I'm going to find out what the y-intercept is. That's when x equals 0. Okay? 0, 0, 5. Y equals 5 when x equals 0. 1, 2, 3, 4, 5. Boom. Now I'm going to say, okay, they give us this point, 2, -3. 1, 2, 1, 2, 3, down there. Okay. I can find the x-intercepts. How could I find these x-intercepts? We could see if this is factorable. I'll go ahead and do a little box here. I'll do a little diamond. We got x squared and 5. And this is 5, and this is -6. That would be -1 and -5. So -5x, -1x. X and x. -5, -1. So if we do x minus 5 times x minus 1 equals 0, then x would have to equal 5, or x would have to equal 1. That's zero product property. So when so what this means is when x equals 5, y equals 0. And when x equals 1, y also equals 0. So I just did some nice handiwork there to find my x-intercepts, which is very nice and possible to do there. So I do also have these points 1, 0, and 5, 0. Now, here's where I can start to use that 5-point method thing. Corresponding points here say that the vertex will lie somewhere immediately in between, which once again, these are 1, 2, 3, 4 away from each other, which means the vertex axis of symmetry is on this line right here. This value is x equals 3. So let's find out what y equals when x equals 3. This is where you actually do have to do some work. So you substitute 3 for x, just like I'm doing up top here, or just like it was done up top here. So this is 9 minus 18 plus 5, which is -4. So your y value is -4 when x equals 3. And that is your vertex. What does that help me do? It helps me find from here on out corresponding points. If this point is 1 unit away from the axis of symmetry, on the other side should be another point that's 1 unit away. So when x equals 4, y also equals -3, just like x equaled 2. And then, way up here, this is 1, 2, 3 units away from the axis of symmetry. So 1, 2, 3 units away should be another point way out here when x equals 6, y also equals 5. So notice how I only had to use the table one more time here. That was to find the vertex. The rest, take a look at this symmetry. Here's your vertex, as we found out. Then you have points here, -3, -3, that are the same, 0, 0, that are the same, and 5, 5, that are the same. Because these are corresponding points right here that are on opposite sides of your axis of symmetry. And now let's go ahead and finish this graph off by putting these through these points, sorta. And there we go. There's your graph for y equals x squared minus 6x plus 5. You can use the table, but you already know how to do that, and I showed you one example of it, they showed you an example of it, so I wanted to show you an alternative method for doing that. Okay, so I think we answered most of the questions that they're going to ask us down here next. What are the coordinates of the vertex, the highest or lowest point? The vertex is down here. That point was 3, -4. Notice how that was your vertex, 3, -4. Find the values of a, b, and c. Calculate the value of -b over 2a. We're not going to talk about this part too much at this point. We're going to work on things with graphs here. You're going to do that more in Algebra 3, 4, but we'll still calculate it. A is 1, b is -6, and c is 5. So -b over 2a is the opposite of -6 over 2 times 1, which is 6 over 2, which is 3. I'm not sure if they're going to ask you about what that does later. Doesn't look like it. But what -b over 2a gives you is the x value of your vertex. You still have to find the y value by substituting 3 in for x, so we did that exact same thing up here. But the way we found our x value was by finding the difference between, or the halfway point between any corresponding points like these two x-intercepts here. And negative b over 2a, by the way, is also visible here in the quadratic formula. Here's negative b over 2a, and that part really does matter for something. That could be explained. I might have explained it in one of the classes, how you can use that to find the rest of what all this stuff means here. Okay, solve the equation. Okay, so you know what? We did some of this factoring. So let's go and rewrite that up here. So this was x minus 1 times x minus 5. If you really have to look back, let's do that. 5, negative 6, negative 1, negative 5. So here are our factors. So we then use the zero product property. We say either x minus 1 times x minus 5 equals 0. I mean, we write that equals 0, so either x minus 1 equals 0 or x minus 5 equals 0. Now remember, I just did this up top. So x either equals 1 or 5. So your x-intercepts are 1 and 5. So notice how I should have kind of done this stuff first. We found out what the y-intercept was. That was 0, 5. We substitute 0 in. Y becomes 5. Okay. Axis of symmetry, we found what that one was. It was way up here at x equals 3. Right? Again, this is speed up time for me. Mirror points. I called them corresponding points. I'm going to call it that. Mirror points makes more sense, I guess, but it sounds weirder for me. So they reflect across. So we listed some mirror points. So notice how these, notice how the green, like these green ones mirror across the axis of symmetry. These red ones mirror across the axis of symmetry. You could pick any points. Even these 2 points mirror across the axis of symmetry. But these are well-defined points that we were able to use. And those are 7 points in our parabola. It's a very nice way that we were able to do that. Okay, now I'm going on to your actual homework stuff, the things that you had in your homework itself. Starting with number 122. And again, I kind of low on time here. For the graph the line at right, let's find the slope. The slope is your rise over your run. And if I consider rise to be up, then I consider run to be right. So as I run to the right, you pick some distinct points. This is a distinct point. This is a distinct point. As I run to the right, how much do I rise? And technically, we're falling. Means if we fall, means your rise is negative. So we ran from 0 to 6 in the x direction. That's 6. We fell from 4 to 0. That's negative 4. So your rise over your run, your change in y is negative 4. Your change in x is 6. That reduces to negative 2/3. So your slope, the m value in y equals mx plus b form is negative 2/3. The y-intercept is right here, the value of y1x equals 0. That value is 0, 4. Or your b value is just 4. So the equation of the line in y equals mx plus b form is y equals negative 2/3 x plus 4. By the way, a lot of times I see people write the slope as negative 2/3 x. X is not a part of your slope. X is the independent variable right here that might represent something like time, the number of hours passed by, or whatever. This is your rate right here. When you go 60 miles per hour, you don't write 60x because x is the number of hours. That would give you how many miles you've driven after so many hours, not the rate. Find the equation of a line perpendicular to this one that passes through the point 0, 7. All right, so we have the equation y equals negative 2/3 x plus 4. In order to get a line that is perpendicular to this, we need to find the opposite reciprocal slope of negative 2/3. So if our original slope is negative 2/3, then the perpendicular slope of that is positive 3/2. You change the sign, and you flip the numerator and denominator. So now we're going to have a new equation that says y equals 3/2 x plus b. And what we would do next, if it passes through the point 0, 7, that means that 0, 7 for x and y would be a solution to this equation. Now, normally I would substitute 0 for x and 7 for y and solve for b and then rewrite my equation. However, b represents y-intercept. This point 0.07, if you recognize it, it's already a y-intercept. I wouldn't have to substitute 0 for x and 7 for y, because b is going to end up equaling 7 anyway. The point 0.07 is a y-intercept right there. And we can go ahead and write y equals 3/2 x plus 7. But ordinarily, like I said, if it's not a y-intercept, substitute that number for x, that number for y, solve for b, and write what b is. To confirm this by graphing, let's go up 3 over 2 with a point, down 3 to the left 2, like that, down 3 to the left 2, etc. And our line should look straight enough, I think. Let's try it. Our line should look a little something like that right there. And you can see where that perpendicularity is coming in right here. These are right angle. If you tilt your head to the right just a little bit, you can see where that's going through. And it passes through this point. We're good to go. That's our equation. Number 123. Factor and use the zero product property to find the roots / x-intercepts / zeros of the following equations. These all mean the same thing. So x-intercepts are roots. They also are called zeros. They're also called solutions. I should write that as well. So if on a test they're only giving you one, if they say find their roots and you ask me what it is, I'll tell you. I'll say that means x-intercepts. But you have to know that x-intercepts means the values of x when y equals 0. So in this case, we have to make sure these are set equal to 0, and they are. And as long as these are factorable, I'm going to go ahead and factor each and every one of these. This one might be a good challenge one to work on. So right here, if you use generic rectangle, and by the way, I never grew, I mean, you know, this is just me saying what I need to say. I've never grown up using generic rectangle. This is a great way to build and find out, and foolproof way to work these problems out. That's fine. In the end, you really want to know what's happening at this point right here, how the factoring is coming into play. Two numbers are adding to -7 and multiplying to 12, and you need to figure out how it turns into these parentheses right here and what basically happens in this factoring point. If you practice this enough and you recognize the pattern that's happening each time, I really want you to see if eventually, someday, especially when it comes to Algebra 3-4, that you find the means to do this mentally. Okay, like for instance, I haven't done this worksheet yet. This is my first time doing it, and what I'm going to do is try and do part B without using generic rectangle at all. And I'm going to do it right now. Here we go. Just count me. Go. Crap, so both negative. 3, 4, 2, 5, 3, 4, 3, no. 3, 2, 4, 5, 5, 6. Well, I didn't do this as quickly as I thought I would. Two, 10, 2, 5, 4, 5, 4, 4, 4. I did not do this as quickly as I thought I was going to. This one's actually not so easy. No. Okay. I'll explain to you what I'm doing. This is going to be x times something and x times something, right? Right now, what I'm doing in these blank spots right here, I'm trying to write down my factors of 6, like 6, 1, 3, and 2. And over here also 6, 1, 3, and 2. I'm trying to take those numbers, and over here are my factors of 20. And I think I'm missing some of them every time I'm doing this. 10, 2, 4, 5, 20, and 1. If I'm using 6 over here, then I have to use 1 right here. 6 times something is going to go here. 1 times something would go here. And I'm subtracting both of them because the product here is positive and this part here is negative. This is the slowest I've ever gone doing one of these before. And so now what I'm doing is I'm checking my factors using 10 and 2, 4 and 5, 20 and 1. I'm trying to see if any of these would fit to make this work here. So I'm going to try this, just a last ditch effort. Going to see if I can do this one last time. If not, I'm going to give up and go your box way, because apparently that's going to be an easier way this time. I don't think 6 and 1 work here. 6 times 2 is 12. 1 times 10 is that, and so I'd get negative 22, but that wouldn't work. So that's close, but that wouldn't work for these 6 and 1. 6 and 4 is 24. 1 and 5 is 5, so that's not give it to me. Or 6 and 5. 6 and 5. 30. No, that doesn't work. 6 and 21. Okay, so it's not going to be 6 and 1. So it looks like it's going to have to be 2 and 3 if this is factorable. So let's try 3 and 2. So 3 times 10 is 30. 2 times... no, that's not going to work. 3 times 2... 6... 2, no. Okay, so these are gone. 3 times 5... oh, I did 3 times... oh, I guess that did work. 3 times 5 is 15. 2 times 4 is 8. 2 times 4 is 8. That's what I did the first time, but I did minus 4 instead in my head. No wonder why it was taking so long to figure out. So it's going to be 3x minus 4 times 2x minus 5. So I'm going to cut out a lot of stuff here. Alright. So if I did this with the box, and now I just killed my own time by doing this problem. You should have skipped ahead. I feel bad now. If I did this way, this would be 6x squared and 20. 6 times 20 is 120. And as you can see, this would have been a hard problem anyway. You still need to figure out factors of 120 here. And those numbers, I guess, are negative 15 and negative 8. So once you find those out, I mean, there's still work to be done here. You still have to pick these numbers, 6, 1, 3, 2, etc. But I think it would have been more obvious once you have these numbers and you know them, which numbers have to go where. So there we go. 3x minus 4 times 2x minus 5. Now that equals 0. Alright, now that I've completely wasted your time in this video, I do apologize. I don't even want to explain it. If you want to learn how to do these mentally, see me, and we'll do some practice with these, because they're great once you start doing them mentally. So 3x minus 4 equals 0. 2x minus 5 equals 0. So 3x equals 4. X equals 4 thirds. Or 2x equals 5. So x equals 5 halves. So these are your two x-intercepts for that one. Okay, this one right here, as you go ahead and factor through, what might be important to do is to write this as x squared plus 0x minus 9 equals 0. So this one here, you have x squared and negative 9. By the way, somebody might have asked in this generic rectangle... oh, never mind. I was going to say why that number became 120. It's because I did 6 times 20, and that's why the diamond, it said 120. So two numbers that multiply to negative 9 and add to 0 are 3 and negative 3. 3 minus 3 is 0. 3 times negative 3 is negative 9. So 3x and negative 3x, we get x and x, 3 and negative 3. So x plus 3 times x minus 3 equals 0. So x equals negative 3 or 3. As you go through. I'm not going to work through the rest of the way. You do the rest as you go, but that's your setup as you solve for those the rest of the way. And this last one here, x squared and 36, diamond. Like I said, it would be nice if you did this mentally. 36 and 12. You'll get 6 and 6. So you get 6x and 6x. X and x. X times 6 is 6. X times 6 is 6, or 6x. 6 times 6 is 36. We have x plus 6 times x plus 6 equals 0. Now, it would be weird to say if x plus 6 times x plus 6 equals 0, either x plus 6 equals 0 or x plus 6 equals 0. It's kind of redundant. You don't need to list this twice. You just need to do it once. In fact, better yet, why don't you just convert this? X plus 6 times x plus 6 is x plus 6 quantity squared. If you square a number to get 0, then that number must be 0. So x plus 6 just must equal 0, so x equals negative 6. And if you have that scenario, actually, that means that your x-intercept is also the same as your vertex of your parabola, which is also an interesting note. Okay, number 124, use the quadratic formula to solve these equations. There's a guess, and I can already see it in both of these, there's a guess that these are also not factorable. So I have to go grab a calculator actually when I get to this. Is there a calculator by me? No. I'm going to have to deviate in a second, do that. Alright, it's good to write what A, B, and C are for this one. We're going to get, I'm going to start with the discriminant of this guy. So I'm going to go and write the quadratic formula up here. I'm going to use the discriminant, the part inside the b squared minus 4ac. So that's going to give me b squared minus 4ac. That's going to be 49 minus 12, which is 37. So we're going to have the square root of 37 inside our discriminant. Now notice that is not a perfect square. Now that I have the discriminant of 37, I'm going to use that in my quadratic formula. X equals the opposite of negative 7 plus or minus the square root of 37. And that is all divided by 2 times a, which is 1. The opposite of negative 7 becomes 7. And notice how now I'm going to split this apart. I know it's a weird number, square root of 37, but let's use this the rest of the way through until we calculate it. X equals 7 plus square root of 37 over 2, or x equals 7 minus the square root of 37 over 2. Now you know the square root of 37 is really close to 6, so make sure that when you do this thing, you could also check with 7 plus 6 over 2 and 7 minus 6 over 2 and see how close you are to your answer. Because here's how I'm going to write this in my calculator. Let me actually do it first and then repeat exactly what I put. So in my calculator, I'm putting open parentheses, 7 plus, and I type the square root button. And it's going to look like this. Square root, and it has a little parenthesis, 37. And I have to close this set of parentheses, and then I have to close this set of parentheses. This gives 7 plus square root of 37 all on the top. And then my divided by button gives me 2. Then I'll hit enter. I'm getting an answer of about 6.54. That's rounded to 2 decimal places. That's one. I should do squiggly lines for approximation. That's one of my answers. The other one is if I do subtraction. So I'm just going to do that on the calculator, and you could follow along if you're doing it. I get x equals about 0.46 as my other x-intercept. So this problem was only possible, as far as you're concerned, through the quadratic formula. We could not have factored this and solved for it because it had this irrational number, this imperfect square. So we had to use quadratic formula. And you can guess we're going to have to do that again, especially when they ask us to use the quadratic formula. So you can try on any problems, and maybe you don't know what method to choose in the beginning. But once you find that something's not factorable, go straight to quadratic formula. My recommendation is start with the discriminant to save yourself time, especially if, and let's see if this is true here, especially if you're taking the square root of a negative number, in which case it is not possible to do. I guess this one is not that case. So we're going to get b squared minus 4ac, that's 25 minus 12, which is 13. So there's our discriminant. Once again, it's not a perfect square, so we're going to have to use the square root of 13 in our quadratic formula. So we get x equals negative e, that's 5, plus or minus the square root of 13, all over 2a, which this time is 3. So x either equals negative 5 plus the square root of 13, all over 6, or x equals negative 5 minus the square root of 13, all over 6. And once again, just be careful in the calculator when you do this. Apply it the same way as we did last time to get that perfect number there. And I don't recommend that you take the square root of 13 first and then round that number, because you will be getting something farther off from your actual answer than you should have. So my first one of negative 5 plus the square root of 13 becomes negative 0.23. Negative 5 minus, that becomes negative 1.43. So those are your two x-intercepts there. And again, this only works when it's set up. Hang on. Okay, this is only possible when this is set equal to 0. So you have to get 0 on the side in order to use ax squared plus bx plus c equals 0 to use what a, b, and c are in a quadratic equation. Okay, number 125. Use the graph at right to answer the questions below. One of the lines represents Feng and one represents Wei or Y. Write an equation for each girl's line. So here is Wei right here, and we have to use some, y equals mx plus b. Let's find out Wei's slope and y-intercept. So Wei has a y-intercept of negative 12. So we know that this is going to be something x minus 12. Let's find out what that slope is supposed to be. Pick two distinct points, like 0, negative 12, and like 2, 0 right here. I can use rise over run here. We rise 12, and we run 2. Now, these aren't scaled the same. These, with every increment, looks like it's 3 units. 3 units. These looks like it's every 1/2. So you just have to make sure that you notice what the numbers actually say. This is still a rise of 12 and a run of 2. So if Wei's slope is 12 over 2, that becomes 6. So Wei's equation is y equals 6x minus 12. Now I don't think they tell you or ask you to say what this means. But remember, this is riding a bike? Okay, yeah, so this is riding a bike. So what this means is that, notice how the distance is your y value. This is rise. This is miles over hour, so miles per hour. So basically, Wei rides her bike at 6 miles per hour. The y-intercept isn't a great one because saying she started at negative 12 hours isn't really a pretty way of saying something, but I'm sure we can give use to what that means because this is really relative to when Feng rides her bike. So let's find out what Feng's equation is. So we get y equals, so her y-intercept is 0. So we're just going to have some sort of slope. So let's use the point 0, 0. Let's use another distinct point. I think this is one right here. It's not a great one. Oh, you know what? This might be one right here. That looks a little better. Here's one. All right, so it looks like this slope is consistent. I'm going to go and use this one. This point is 12, 3. 12, 3. So you rise 12 and you run 3. That one's a good one. 12 over 3 is 4. So y equals 4x. So Feng rides her bike at 4 miles per hour. But you can see she kind of got a head start. So they meet at some point there, and I'm sure that's part C. How fast does each girl ride? So I guess I could have put this down here. Wei rides her bike at 6 miles per hour. Feng rides her bike at 4 miles per hour. So you can see that Feng is slower, but she started earlier. Wei started 12 hours later, and she's eventually going to catch up to her. When do they meet? How far away are they from school? I don't know. I don't think they say where school is. Maybe they left school. Okay. So when did they meet? That's that point of intersection right there. What you could do is you could set their equations equal to each other. Let's say you didn't have the graph. We could set this up using equal values method. Subtract 4x, add 12, divide by 2. We'll get x equals 6, which matches what it shows right here. X equals 6, boom, right there. And then you could find out how far away, I'm guessing this is school. How far away are they from school here? Looks like they're 24 miles away. How else can you double check? Substitute 6 into either equation for Wei or Feng. 4 times 6 is 24. 6 times 6 is 36. Minus 12 is 24. So your y value, how far away, to answer that question there, is 24. I am losing time here. I'm gonna go a lot more quickly. Okay, I'm going to try and do my method once again. This time it's going to be a lot easier because I know this has to be 3x times x. These both have to add. I'm going to use values that multiply to 30, such as 5 and 6, and in fact I think that works. If I do 3x times 5, that's 15. X times 6 is 6x, and you get 21. That will be the factor. I'll go ahead and do the box super quickly for you. 3x, shoot. 3x squared, 30. 3x squared times 30 is 90. 90 here, 21 here. You have to find two numbers there. That'll be 15 and 6. And that becomes 15x and 6x. Oh, you know what? I'm not even done with this problem. I can factor out a 3 from the front. Probably should have done that from the beginning. Anyway, 3x can fit in either one of these here. Now notice how this ends up looking different from what I originally had. This one says, oh, that should be x plus 2. This one says 3x plus 15 times x plus 2. So how did I get something different here than I got right here? Well, because there's still a common factor of 3 that can be pulled out, which means those are two unique rectangles that can be made. If I pull out a factor of 3 here, you'll see that I get the same thing here as I got right here. So both of those are the exact same, and we met up. I know, I'm running out of time. 7x squared minus 63. I can factor out a 7 first. If I factor out a 7 first, this will be x squared minus 9. I learned my lesson. X squared minus 9 factors 2. We just did this before, so I'm not going to do it again. X plus 3, x minus 3. So your final factor is 7 times, if you factor that, x plus 3 times x minus 3. Find the coordinates of the x-intercepts, y-intercept, and vertex of x squared minus 2x minus 15. Show all of your work. Might be helpful to graph to find the vertex part for the x-intercept. So the y-intercept is when x equals 0. This becomes negative 15. So 0, negative 15 is your y-intercept. Your x-intercept, oh my gosh, how much? Okay, I have one more problem after this. Your x-intercepts are when y equals 0. Find out how this factors. I'm just going to go ahead and write it for you. This is x plus x minus 5 times x plus 3 equals 0. And you solve the rest of the way, you get x equals 5 and negative 3. Once you find those are your x-intercepts, 5, 0, and negative 3, 0. Once you find those, if I put these on a graph, you know, like 5, 0, negative 3, 0, those 2 points, your vertex should be right in between those, like the point between 1, 2, 3, 4, 5, 6, 7, 8. So half of 8 is 4. 1, 2, 3, 4. So your vertex will be somewhere down here on the line x equals 1. That's your axis of symmetry. How do you find the y value? Substitute 1 for x. 1 minus 2 minus 15 is negative 16. So your vertex is 1, negative 16, which would be way the heck down there. I don't think they asked us to graph this, but it would do something like that. I am totally rushing at this point. I'm so sorry. I spent so much time factoring that one problem. Last one. Quinn started off with twice as much candy as Denali, but then he ate 4 pieces. When Quinn and Denali put their candy together, they now have a total of 50 pieces. How many pieces of candy did Denali start with? Show all of your work. Okay, so I will let Q equal amount of candy for Quinn. I will let D equal amount of candy for Denali. I'm so sorry, guys. I want this for you. Quinn, Quinn has twice as much candy as Denali. So Quinn starts off with Denali's amount of candy times 2. But then he eats 4 pieces of his own candy. So you take away 4. He had twice the amount, and then you subtract 4. Quinn and Denali put their candy together, and you get 50 pieces. So now we have this system of equations here. We have Q equals this, and Q plus D equals this. So I can substitute 2D minus 4 for Q over here using the substitution method. I'll get 2D minus 4 plus D equals 50. 2D plus D is 3D. 3D minus 4 equals 50. 3D equals 54. Divide by 3, D equals 18. So to answer the final question there, I got to finish. Denali started with 18 pieces of candy. Awesome. All right, that's it. Again, kind of faulty stuff that I had for you in the factoring part, and I'm sorry, and I know I rushed through some of it saying, you should be able to do it on your own, but at least this serves as an answer key for you as well, and I hope a lot of this stuff made sense. Your test is upcoming on Wednesday, so make sure that if you have any other questions that you do ask. Okay, this wasn't all encompassing, but this did have some nice problems that cover some old review stuff. And if you do have any questions, please let me know. I am here for you guys. Have a good day.